everyone, it's great to have you here. Today we have a very special episode with Microsoft Senior Program Manager Theo van Kraay, and he'll be taking us through building multi-tenant apps with Spring Data and Cosmos DB. So without further ado, Theo, do you want to do a brief introduction?
Sure. Yeah. Thanks, Tara. Yeah. So, well, shall I go straight into it and start? I have some slides here. So
Yeah, go for it.
let me just show my screen here. Let me know when you can see things.
Yeah, I think it should be coming up soon. I'm not quite seeing it. Do you want to refresh one more time? Oh, there we go. Okay, perfect.
Oh, can you see it?
Yeah.
Yeah. Okay. Technical problems out of the way. Okay. Yeah. So I wanted to talk about building multi-tenant apps with Spring Data and Azure Cosmos DB. But first of all, I wanted to talk about what is a multi-tenant app, right? Because I don't want to assume that everybody who's listening and watching necessarily knows everything about multi-tenancy. Certainly, I know plenty of developers who've built apps for years before they even had to think about multi-tenancy or building a multi-tenant app. And of course, you can go to Google or Bing or whatever, and you can go to Wikipedia and find a definition. And it's okay. And I guess this probably sentence sums it up best, at least in this definition. A tenant is a group of users who share a common access with specific privileges to the software instance. And I like this line at the bottom. Some commentators regard multi-tenancy as an important feature of cloud computing, that's for sure. But I prefer thinking about this in terms of analogy that almost certainly was the basis for this term, right? So imagine you're a landlord and you're building a property and you want to rent out space to tenants. And you start by building a fairly small property and you have lots of small rooms and you want to rent these rooms out to as many tenants as possible, keeping your costs down. And you think that this is going to make you a bunch of money. And then one day, some rock band moves into one of your apartments and starts making a lot of noise and keeps all the neighbors awake. And then you've got a noisy neighbor and unhappy tenants. So then you go to the other end of the extreme and you start building luxury houses that are nice and discreet and detached and isolated. And all of your tenants are really happy. But they didn't pay you much more rent than they did previously. And in the meantime, you spent a bunch of money. And so that's not good either. So this is exactly the trade-offs that are involved in building multi-tenant systems. It's really exactly the same thing. You're really trying to get as high density as possible. That is more tenants per physical resource than less, with obviously the low cost that comes with that. But of course, the trade-off is low isolation. You might have noisy neighbors or other problems associated with that. And then at the other end of the spectrum, when you want to mitigate that, of course, it means higher cost. So why is Azure Cosmos DB great for building multi-tenant apps? Well, I guess the first thing to say is Cosmos DB is, of course, itself a multi-tenant system. It's built from the ground up to be a multi-tenant system and to allow customers and users to build multi-tenant apps easily. And if you think about the definition, let's use the definition that we had before. Systems designed in such a manner are quote unquote shared rather than dedicated or isolated. Well, in Cosmos DB, the fine-grained multi-tenancy that we have, and specifically the resource governance that we have, which is at the software level, is such that we can guarantee prevention of things like noisy neighbor issues. Hence, your system is effectively both shared and, for all intents and purposes, isolated and dedicated. And so the proof of this is with our throughput SLA. It's not the most talked about SLA. Usually when we talk about Cosmos DB's comprehensive SLAs, we're usually talking about the latency SLA or the availability SLA, 5 nines of availability and so on. But we have a throughput SLA. And what this means is if you deploy a container or a database and you provision, let's say, 10,000 request units, that is what you'll get. You'll get 10,000 request units. It doesn't matter how many request units some other customer is using on some other account that may or may not be sharing physical resources with you at the platform level. You will get that throughput. So I guess you could think of this as giving you the best of both worlds. Cosmos DB kind of slots in the sweet spot between being able to, navigate these trade-offs and concerns. And you can also think about this with the analogy in terms of, you get the price point, roughly speaking, as if you'd bought, let's say, a big set of high-rise flats, but you still get some level of isolation. So that when you get those noisy, what would otherwise be noisy neighbor issues, you've got some level, some way of keeping your tenants happy. So one of the ways that we express this, I suppose you could say, is with the multiple different options that Cosmos DB gives you for tenant isolation and also security isolation as well. So you have things like partition key per tenant, container per tenant with shared throughput, container per tenant with dedicated throughput, database per tenant, and database account per tenant. And you see in this table here, we've listed out the various areas of concern when building a multi-tenant app, and how each model will serve you for those concerns, whether it be performance isolation or security isolation. And this table is taken from a generic doc that we have on Cosmos on multi-tenancy in Cosmos DB. I definitely would recommend checking that out. By no means am I covering all of the concerns and things that you want to be thinking about if you're building a multi-tenant app. But there's certainly some information there that you can look at. So what about the multi-tenant apps that run on Cosmos DB? And again, this is one of the proofs of the pudding. Well, we have a few apps that are multi-tenant apps that are running on Cosmos DB. Just a few little small ones here, things like Skype and Teams and Bing and Xbox Live and Office 365, Azure Portal, LinkedIn. Of course, I have to mention ChatGPT. So obviously these are monster multi-tenant systems and applications and services, and obviously they need to navigate the trade-offs between high density and performance isolation, security isolation, and so on. So obviously these systems are trusting Cosmos DB, and many thousands of external customers are doing the same as well. So, okay, so hopefully we've established that Cosmos DB as a platform is a good platform for building, a very good platform for building multi-tenant apps. In fact, it's one of the its strongest areas is in this space. So what about multi-tenancy for Spring Data? Well, again, I don't want to assume that everybody watching knows Spring Data or knows what Spring Data is. If you're a Java developer, you'll certainly have heard of it, even if you're not using it. It's a framework built in Java. It's part of a wider ecosystem in the Spring framework. It's a project that whose mission, as you see here, taken from the website, is to provide a familiar and consistent programming model for data access while still retaining the special traits of the underlying data store. So basically, it's an abstraction layer. It makes the boilerplate stuff of connecting to a database more straightforward for the developer, so your speed to market is greater. But it also means that the code that you write can be consistent regardless of the database that you're connecting to. You typically will create a repository that defines the data store that you have, and that will have some generic methods that you can use, but you can also create methods, and when you're creating methods, you can even name them by the actual thing that you want to do. So for example, here I want to define a method that finds by ID and last name, and Spring will do its magic in the background using the client library for that particular database to construct the query that's needed to find the data. And the key point here is the code that you write will be the same regardless of what database you're connected to. So you can pretty much swap out the controller and repository code, or more or less, from most applications built with Spring Data between one database and another with very few changes. So that's one of the goals of Spring Data. And of course, Spring Data is a really popular project, and there's many databases that have committed to this with modules, and not least, of course, Azure Cosmos DB. We have a Spring Data client library and module for developing on Spring Data. All right, so that's a very high-level whistle-stop tour of, I guess, multi-tenancy at the high level, the challenges, the trade-offs, and what Spring Data in general has to offer developers. So, what about Spring Data with multi-tenancy? Are there challenges there? Can you use Spring Data to build multi-tenant apps? Well, I guess we could start with talking about what the typical patterns are, or at least one typical pattern. I don't mean to suggest that this is the only pattern, but a common pattern, let's say, that we see when customers are building multi-tenant apps is they'll want to pack as many tenants as possible into the app tier, because obviously, stateless code, you're not going to run into as many noisy neighbor issues there. So you want to pack as many tenants as possible into your app instances. But when your application's talking to your database, what we see is there's a tendency to want lower density there, want more isolation. So how that transpires is you want your app to be able to dynamically talk in some instances to different instances of different databases dynamically, so that you can have isolation at the data access layer. The problem in Spring, historically at least, has been that this isn't really understood by default. So the default configuration of Spring Data is that you define a database, you'll define entities, and those entities and database will be tight coupled to that application at runtime, at project startup. So that means that if you want low density and you want, let's say, one tenant per database, you pretty much have to have one app instance per database in the default configuration. Obviously, this can be quite cumbersome, not to mention time-consuming and expensive to set up. So I guess that brings me to the changes that we have done in the Cosmos DB Spring Data client library, our module for Spring Data, to make this easy and to make it possible and more straightforward to do this kind of multi-tenancy where you want more isolation at the database layer, but you still want high density at the app tier layer. So I'm going to do a little demo here. Before I do it, everything that you're about to see, every line of code, is available in some sample apps. There's a link to a blog here that I wrote about this, so you can follow that through and read that through if you want. You won't miss anything. Let me just come out of here.
Yeah, while you're bringing that up, just wanted to throw in one question that I had, and this is basically like, why would customers choose to use maybe the Cosmos DB Java SDK instead of using Spring for building their multi-tenant applications?
Right. Yeah, that's a great question. Of course, the challenges that I'm kind of alluding to with Spring wouldn't necessarily be there if you're using the core SDK, because the core SDK just gives you direct access to everything, and you have all of the control there. More obviously, one of the benefits of Spring Data would be just the ease of use and just the fact that it takes the boilerplate code away from you and increases your speed to market, let's say, so how quick you can build an app. That's one of the obvious benefits. Of course, there's a trade-off there, though, because with any abstraction, the idea is to make things simpler, and sometimes the control you need is complex, so you have to step down into the SDK to do that. But that's one benefit. Maybe a less obvious benefit of using something like Spring Data, and we do see some customers do this. Not in all, maybe not as many as I would like, but we do see it. What you often find, especially if customers are deploying applications where they have a cross-cloud deployment need, let's say they're deploying to Azure and another cloud, let's say, they want to deploy to different environments. They often want to standardize on one database, let's say, because they think, well, I don't want to choose a database that isn't available in other clouds. I don't want to choose something proprietary, and this will prohibit them in their minds from choosing something like Cosmos DB or even another cloud native database let me think of one, Dynamo, is it, in AWS, or, Google Store, those kinds of things. And I want to sort of maybe do a favor to our colleagues in those cloud companies and say, this is maybe not always the best choice, and not to be too controversial, but you aren't going to be able to get the same kinds of availability and performance guarantees from, let's say, other databases that you will get from cloud native services like the ones I've just mentioned. So why inhibit yourself by tying yourself to a database protocol? Why not abstract at a layer above that? And this is what something like Spring Data will allow you to do. As I kind of alluded to before, if you are using Spring Data, the abstraction is above the database. When you're writing your code, you can swap that out fairly easily to another database, and your application code will look pretty much the same. But this gives you the option of deploying to what you might say best of breed data service, data platform within the respective environment that you're deploying to. So that's one benefit. Certainly, we do see some customers taking this approach. Rather than standardizing on a database, they'll have some abstraction layer. It might not be Spring Data, but sometimes it is. Because they want to deploy to the best service possible, the one that gives them the best SLAs, and Cosmos DB is right up there in terms of SLAs across performance, right? We have SLAs for availability, latency, throughput, and consistency. So, if you have a cross-cloud deployment need, a multi-cloud strategy, this is definitely something worth thinking about. So that was my very long answer to your very simple question. Why would somebody choose Spring Data over the core SDK? You could certainly use both, but there are some of the advantages of Spring Data.
Got it. Yeah, thanks for the explanation. I think that covers my question, so we can go right into the demo.
Right. Okay, so let me just show, as I said, this is all available in the links and the samples and everything. So I've just got an empty NoSQL Cosmos DB account here. And I'm going to go straight into my code for the first sample. So this is just a simple REST app. For those of you not familiar with Spring Data, what you would typically do when you're setting up an application that uses Spring Data is you'd define a repository class, which would just extend the repository class for the particular module that you're using, which itself would extend the Spring Data repository APIs. And then you would have an entity that defines how your records will look. And then you would have some app config that would just pull in as Spring Beans the specific resources that you need to allow for Spring Data to do the auto wiring that it needs to do. And then your controller code would just be very simple calls to very generic methods, and also custom methods if you need to write them, that are very well abstracted. So, there's not a lot of boilerplate code. It's very simple to do this kind of thing in Spring Data. I'm not going to give a whole class on Spring Data. I'm sure folks watching will know what it's all about. But in case you're not aware of it, this is what it's all about. So what typically would happen, as I was kind of alluding to before, is you'd set up your credentials in a properties file or a YAML file, and there would be a class that defines the credentials that you have there, and those will be pulled into your app configuration class here. And that would be, as I said, it would be tight coupled to the application at startup time. So you would just have a database that's created. So let me just go ahead and run this application here in debug mode. And let's see what happens when I run this. It's going to take a little while to start up. So what that should be doing is just creating the default resources that I've defined. And if I refresh here, I should see tenant template DB, and I'll see the entities that I defined automatically created, because those were the entities that I defined in my two repositories that I've got here. I've got an order repository and I've got a user repository, and those are defined with the user entity And in the order repository, I've got the order entity. So I'm getting what I expect. And typically, if I didn't do anything else at this point, then there's no way within the API itself that I can reference another database dynamically. I would have to deploy another instance if I wanted to do that in order to support multi-tenancy, which obviously is pretty cumbersome. But some changes that we've added recently, and similar changes have been added to some of the other client libraries for other databases as well, would be what is under this tenant folder here. So I've got a class that I've created, which I've called Multi-tenant DB Cosmos Factory. You can call it whatever you want, but it will extend, and we allow the extension of a class called Cosmos Factory, which is an object that's used internally by the Cosmos template, which is the internal implementation of the Spring Data Repository APIs. So every time a method like save or insert or whatever, update or whatever the method, Spring method is, or even a custom one that you've created is called, it will also call methods in this factory, and we allow you to override the get database name method, right? So in this case, in order to be able to create a database per tenant and reference that database, what you need to be able to do is capture that tenant in some way. And what I've done here, I suppose there are other ways that you could do this. You could use a cookie to capture this, or there's different ways. But in this case, all I've used is the web request interceptor API in order to define a HTTP request header of tenant ID. So I'm expecting tenant ID in the HTTP request. And then have a utility class here that is also going to create my resources. This is all kind of boilerplate. You could literally copy all of these classes into this folder and then define a bean that will activate this Cosmos Factory class, and then you would be turning your existing Spring app into a more or less a multi-tenant app with performance isolation for each tenant if you were doing this. So yeah, what I have here is tenant storage. That's going to create a tenant-specific database if it doesn't exist. It's also going to add the name of that database to a thread-safe list so that I can know which databases have already been created. And it's also handling the capturing of the tenant in the local thread, which is using this API that I already mentioned. So that's all happening when this is invoked. So let's just go ahead and put some debug in here. I'll go into my order controller and I'll put some debug in the create order method. And let me go to the Postman, and I've got a request here. It's a pretty simple request. Oh, let me just, I'm going to minimize this a little bit. There we go. So it's very simple. It's going to create order. And let me get rid of this because that's not what I want. And it's going to pass in a tenant ID of Theo. And there's just a simple body here, just simple JSON, order detail and last name and so on. So what this should do, we send it. I should be catching this in my debug here, and I'm going to step through. So normally at this point, it would just, as I said, be writing to the default database that you provided. But in this case, it's going to drop into the multi-tenant DB Cosmos Factory class and polymorphically call this get database name method that I've overridden. And then it's going to say, is there a tenant ID? Yes, there is. And then it's going to create that database because it doesn't already exist. And then let's have a look if it's created it. And we should see there's another database been created with the entities that I expect, which is great. And if we let this finish, then let's just let this run to its conclusion. I should find that it's created an item as well. And let me just go ahead and also create a user item also, since this entity has been modeled sorry, this tenant has been modeled using two entities. I have an order entity and a user entity. Let me go ahead and create my user entity as well. Is this going to drop into debug as well? Yeah, let me just continue through that. Let this finish. And I should find that this has created. I go down to my user entity, hopefully. Oh, nothing there. Okay, I don't know why that's showing up, but I've obviously done something wrong. Never mind. I would have created a user and order entity. Yeah, demos, live demos. Why does anybody do them? But anyway, yes, there's nothing. Don't worry, there's nothing wrong with the sample. It's 100% the case that there's something wrong with me. Anyway, that will have created a user entity, and so that's fine. So that's great. So let me go ahead and try creating another tenant. Let's see if that works. So I'm going to create. I'm going to send a request. It's exactly the same request, but with a different tenant ID. And what this should do, hopefully, if nothing goes wrong. Yeah, it's got stuck at that point. And there we go. That's what I expect. In fact, you know what? I was looking in the wrong database, I think, here. So if I look in here, no. Worth a try. Anyway, we created another tenant called Dave. And so you can just keep doing this. And obviously, this is how you do multi-tenants at the database level in Spring Data with the new changes that we've added. Now, what happens if you want to do container per tenant? I'm going to
pause right there. I think we have one question.
Sure.
So someone is asking, how is that thread safe list shared if the web server runs on multiple servers?
How is the thread list shared if the web server runs on multiple servers? Well, it's thread safe in the context of the instance of the app. It doesn't need to be thread safe across multiple servers unless you're quite right. If two requests from the same tenant go to two different app servers, so yes, you might have a collision there, and that would you need to control that somehow. But within the context of the app server, assuming that you want to get lots of density on that particular instance and you want that to serve multiple tenants. Then it would be safe within the app instance. But yeah, it's possible you could get a race condition where the same tenant was making a request to two different app servers at the same time.
Cool. Okay. Sounds good. Hope that answered your question. For others listening, feel free to chime in with any of your questions you might have, and we'll bring them up to the screen as well. Continue. Right, so, yeah.
Sure. So let me I just shut down the app that I was running there, and I've got an almost identical app, except this one in my class that extends Cosmos Factory. I've just called this multi-tenant container Cosmos Factory. You can call it whatever you want. But this overrides another method called override container name. It's exactly the same principle. Without saying too much else, let me just go ahead and start the application here. I won't put it into debug mode since that didn't work very well for me before. So let's go ahead and start the app. And let me do exactly the same thing and try and create an order here and see what happens. Right. So what I should have done first is just shown what that did when the app started up. And what it did was create a database called tenants, and that would have had nothing in it. But what that has now done as well, that request that I just sent is created a tenant, which is expressed as a container. And it's created a order record. Now you might be thinking, okay, well, what happens when I create a user record? Where does it go? Does it go to the same container? How does it differentiate between the two? Well, let's just send a user record and see what happens here. I should give it the same tenant ID, of course. Let's send this and see what happens. Did that return something? Not sure if I got a response here. Oh, yeah. Let's some debug on here. Oh, no. This should be fine. This should be sending. Okay. I'm having a really bad day with demos today, but what should be happening is that you should see another record in here. And let me just figure out what's going on here. Oh, I'm in the wrong. Of course, I'm in the wrong. I've set this, somehow left this as a get instead of a post, which is stupid. Let me send this again. Yeah, okay, that's worked as I expected. And what you should have is now two records in the same container, but they're different types. So what is going on here? If you're coming from the relational world, or you think about entities as being, you know, in some sense, tight coupled and standalone, then this is probably going to seem a little strange. But of course, in Cosmos DB, we have this concept of co-locating entities. So what I've done for each entity is defined a field called type. And when I'm sending an order, I'm setting that to order. And when I'm sending a user, which has different fields, I'm setting that as user. So I'm co-locating types. Now, why would you want to do this? Well, the biggest reason is if I want to get all of my users and orders for my tenant, let's say, for example, then I might write a method like this, in which case I would have had to write a custom query. Let's go to that. Because I need to get, because of course I can't cast in the Spring Data world, I can't cast the response to one entity because they're actually two different entities. So I would have to make this a JSON node. But the advantage is that it's only one call to the database. If I look at the equivalent code in my other application, then this would have to be two calls because, of course, Cosmos DB does not support joins between two entities, which in this case means containers inside Cosmos DB. So that's one benefit of co-locating. Even if we did support joins in NoSQL API, the call wouldn't be as fast because it would be joining instead of just bringing back all of the data. You don't need to join between entities. All of the data exists in the same container. It's just we're co-locating the entities together. I know it's a weird concept, and you know, might have to get your head around it, but that's certainly what we'd recommend if both of your entities or all of your entities shared the same partition key. Another reason that you'd want to do this, and you might not have noticed, but I'm going to show you now. For this sample, we're also capturing a HTTP request header of tenant tier, and at the moment it's set to standard. But let's see what happens if we create a different tenant called Abby, and let's give that a tier of premium. And let's see what happens when we send that. So let's go to back to our database, and we've got another tenant there. Let's first look at the settings in the first tenant that I created. If we go to the settings for the container, you see there's just settings with time to live and geospatial configuration and indexing policy. But if I go to the settings for my other tenant that I just created now, I've also got a tab for scale because this container has dedicated throughput and the other container is sharing the throughput that has been defined at the database level here. So another reason that you might want to choose container per tenant instead of database per tenant is if you want to mix and match between tenants sharing the database throughput or tenants having their own dedicated throughput. And you might think of this as a premium or a standard tier or something, I don't know. So I guess the summary then of this would be some modeling tips, I guess, for tenants, whether you're doing a database per tenant or container per tenant. In both cases, you would already have decided that you needed performance isolation for your tenant, so there's going to be dedicated throughput guaranteed. Of course, you could choose partition key as the tenant identifier, but that would have some noisy neighbor problems associated with it. But it still has its benefits in terms of being able to transparently scale on storage. But if you want a dedicated throughput and the tenant can be modeled with a single entity, then honestly, either container or database per tenant would do, unless you also wanted to mix and match, as I said before, between dedicated or shared throughput, in which case you would probably choose the container per tenant model. But keep in mind that there is a limit of the number of containers you can have in a shared throughput database of 25. Mm-hmm. If the tenant model needed more than one entity, in other words, like what we showed before, we had order and user, they were sharing the same partition key. So if they did share the same partition key, you can still have it in a container. You don't have to have a database. And I would say consider co-locating in the same container. There are some extra bits, as you saw. You have to write custom queries. You have to filter by the type in order to get the data back that you want. But it might have performance benefits as well. And also, if you want to mix and match, as I already said. But if some entities require different partition keys, or maybe it's a complex data model that really needs a lot of entities, then you might be better using the database per tenant model. And really, this is only scratching the surface of data modeling in Cosmos DB. It's just these are generic comments actually for modeling, but in the context of multi-tenant using Spring Data or any framework, I suppose. But I really recommend checking out this doc here. For some more in-depth guidance on how to model. If you're new to Cosmos DB and you need to build a multi-tenant app, we would definitely recommend checking out that documentation. Of course, the deeper that you go into it, the further it takes you away from the simplicity that something like Spring Data will give you. But if you're interested and you want to know how to get the most out of it, then it certainly would recommend taking a look at that.
Yeah, this is great. I think like one of the features that I'm currently working on for hierarchical partition keys, I don't think it's currently supported for Java and Spring, or at least for Spring so far. But looking at this, I feel like this is great motivation to get that support running and going, because it'll make it just things so much more smoother for our multi-tenant applications that are running on Java and running on Spring. So yeah, just wanted to plug that, as well as since we're talking to a lot of multi-tenant app users on this show as well.
Yeah, we definitely have hierarchical partition keys on the list for Spring Data. So yeah, as I said, we're really investing heavily. We recently had released support for Spring Boot 3. And we're adding features all the time. Of course, I kind of alluded to it somewhere near the beginning. You can't add all of the features that are in the SDK. If you were doing that, then obviously there would be no point in having an abstraction layer. But certainly hierarchical partition key is definitely one feature that we can add, and there's plenty of others as well that we've already added. So yeah, check it out.
Yeah, awesome. This was great. Does anyone else have any questions? Feel free to drop it in the chat. We still have some time left. Otherwise, I guess, do you have any final thoughts, Theo, on the current presentation or demo or anything else you would like to impart on to our users today?
No, I don't think so. I guess I really rushed through and got the sort of the demo gods were unhappy with me again. So I guess probably the demo was a lot quicker than I would have wanted. I think the only thing I liked your question halfway through. Just reiterate that this Spring Data is obviously everybody knows it's popular. But to reiterate that idea of, consider whether or not you're abstracting at the right place. We do see this very often, people deciding to sort of tight couple themselves to the database simply because it's ubiquitous across clouds. But you don't necessarily need to do that if you have an approach that involves some abstraction layer. It doesn't have to be Spring Data. Obviously, Spring Data is a good choice because it's heavily invested into by all of the major database vendors, be it cloud native or not. And if you're a Java shop, then it's definitely worth considering setting the abstraction layer at that point rather than committing to the database layer, and then this prohibits you from using something like Cosmos DB, which is, would make me very sad.
Right. Yeah. Awesome. Okay, cool. I think we can close there then. It was great having you on the show, Theo, and this was a wonderful presentation. I especially loved your I guess we have one more question. So before closing, we have one more question, and it's, if I use .NET, what do I use instead of Spring?
That's a great question, and I'm not a good person to ask that question. I think Entity Framework is the closest equivalent that I'm aware of, and it does a similar kind of thing. I mean, part of what I didn't really mention this before, but part of what Spring Data is doing is object relational mapping. That's what it's doing. You saw that I defined objects that represented the records that I'm storing, and those are uniform across whatever database that you're using. But it's not really, Spring Data is not quite so much about object relational. Well, actually it is with Java Persistence API for relational databases, but for the other databases, it's not only about that, it's also about giving you a uniform experience. I'm not quite sure. I think Entity Framework in .NET does a similar thing, pretty much the same thing. I don't know whether your code would look the same regardless of the database you're using in .NET, because I haven't tried it out. I'm afraid I'm a bit more of a Java person than a .NET person. Strange thing to say for a Microsoft employee. Yeah.
Cool. Okay, makes sense. All right, yeah. So yeah, just closing thoughts. I loved the analogy you had in the beginning when explaining multi-tenancy. I'm definitely gonna steal it from my presentations as well. But yeah, thank you so much, Theo. And we look forward to having you guys listen in on any future Cosmos DB live teaching episodes. So have a great day. Thank you.
Great. Thanks, Tara.